right, the recording has started, so please mute your mics. Obviously, if you want to add anything, if we want to add a question, I think you can just press the space bar and that should unmute your mic temporarily and then you can talk. So yeah, if you have a question, please stop me immediately, let me know. Can everybody see the screen that I'm looking at the moment?
Yeah.
Yes.
Okay, so, right. This is the video that I wanted you guys to watch yesterday, which is answering questions on circles. Now, I think you guys will realize that the theory for the circle section is very tiny. It is small, 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 small. It pretty much involves how to find the equation of a circle, how to do completion of the square to find the center of a circle and the radius of a circle, then how to find the equation of a tangent to a circle, and that's pretty much it. That's all the theory. But then if you watched this video yesterday on answering questions of a circle, you'll realize there's a lot more to it. And the reason there's so much more to answering questions on circles has to do with the 3 sections of work they bring into this section. The first section they bring into this is obviously analytical geometry. So all the analytical geometry, you know, your gradient formula, your midpoint, your line equation, all of that comes in here. So you have all of your grade 10 and 11 analytical geometry that's in here. Then you also have quite a bit of your grade 11 and Euclidean geometry in here. Because you guys saw, we need to know the tangent is perpendicular to the radius. And you'll see there's a couple of other stuff I'm going to be talking about today. Like for instance, tangents from the same point are equal in length. Or if a line subtends a 90-degree angle on the circumference of a circle, it's got to be the diameter. So all of those circle properties that you learned in Euclidean geometry also gets used over here. And then thirdly, functions. Because functions and graphs, if you think about it, they can ask you what is the x-intercept of a circle, and you have to know, oh, x-intercept set y equals 0. Or they can ask you what's the y-intercept of a circle, and you go like, oh yes, y-intercept, I have to set x equal to 0. And then also you need to be able to find the point where a circle and a straight line intersect. So you have to know, oh yes, I solve the equations simultaneously. So all the knowledge you have to have on functions also apply here. And that's why you need to go and start working through the past paper questions, and you need to realize this does not work in isolation. It's analytical geometry combined with Euclidean geometry, combined with functions and graphs. And this can make the questions fairly tricky. What I've done is I've gone and I've looked at every single IB past paper. And I've just gone and I've put together a list of the type of questions that recur, that repeats again and again and again. And then yesterday's video on answering questions on circles showed you some of those questions that appear again and again and again. So today what we're going to look at, answering questions on circles part 2. So I'm just going to continue. I did the first 4 of these questions on circles in the video yesterday. And what I'm going to do today is I'm going to continue with these ones. Hopefully if we get past this through this quickly enough, we can go back to yesterday's ones. And if you had any questions after watching yesterday's video, you can ask me about it. Okay, so let's get started. Now, the 5th type of question they like asking in these questions on circles has to do with a perpendicular bisector of a chord specifically. Now, in the revision on the grade 11 analytical geometry earlier this week, I spoke about how to find the perpendicular bisector of a chord. So the perpendicular bisector of a chord, pretty much what you need to do, you need to find the midpoint, so the middle right there. So if you have these 2 coordinates, say for instance this is A and this is B, and you say this is then the middle such that from A to M is equal to M to B. So if we call this point M. Got it. So use the midpoint formula to find that. Then you use the gradient formula to find the gradient of AB. And once you've got the gradient of AB, you know that the perpendicular bisector will be at a 90-degree angle to that. And I did give you a very nice Luzandi method style where I said step 1 to find the perpendicular bisector of a line. Step 2, step 3. So obviously step 1, find the midpoint. Step 2, find the gradient, and they know that the gradient is perpendicular. Then you have a point on the line, you've got the gradient, and then you just sub it into the formula. Now, why am I talking about this again? I'm talking about this again because of a very, very important property of these perpendicular bisectors. Not just of one chord, but the moment I draw another chord. So if I draw another chord, say up here, and I say, for instance, this is then the point CD, so that's on the circle circumference, and that's on the circle circumference, so that's the chord of a circle. So again, what I do is I find the midpoint. So that is equal to that. So obviously I can't call this point M because I called this one point M. So I'm going to call this point E, which is then the midpoint of that chord. And then I again draw that perpendicular bisector, so I draw that 90-degree line. Then something that you really, really need to know, and this is knowledge, you have to have this in your head, is the following. Where the two perpendicular bisectors cut is the center of the circle. And the reason this is the center of the circle has to do with your Euclidean geometry theorems, the first and second Euclidean geometry theorem you learned last year. In the first and second Euclidean geometry theorem, it said, a line from the center perpendicular to the chord bisects the chord. The second one said, a line from the center bisecting the chord is perpendicular to the chord. So you have three things happening there. You have the center, you have perpendicular to the chord, and you have bisects the chord. So if I then go and I say it's a perpendicular bisector, then you have it bisects the chord, it's perpendicular, therefore the line must go through the center. So this line must go through the center. This line must go through the center. So because both lines go through the center, where they intersect is the center of the circle. So let's write that down so you can remember this, because like I said, this is very important. If you don't know this, you're going to get super, super stuck on some questions. So if you calculate the perpendicular bisector of two chords, the point of intersection between the perpendicular bisector of two chords will always be the center of the circle. So very, very important information. The point of intersection between the perpendicular bisector of two chords will always be the center of the circle. By the way, if I had drawn another chord in there and I'd gone and I'd drawn the perpendicular bisector there, it would have gone through the same point. But you don't need three perpendicular bisectors, you just need two of them. Is everybody okay with finding the equation of a perpendicular bisector if those 2 points are given? You understand exactly how to do that. You've looked at that video, the revision of the grade 11 work, you've seen the steps to do this. Everybody okay with that?
Yes, ma'am.
Okay, excellent. Right, so let's look at some questions where they use this. And the interesting thing is, you'll start doing the question and then you'll get stuck on something where you'll go like, ooh, I've got no clue how to do this. And then if you start thinking about all of these tips that I'm giving you, you'll suddenly realize, oh, that's what they want. So this was question 11 in last year's paper 2, the supplementary paper 2. Now it says, question 11, in a diagram below, two circles intersect at C and D. So those are the points of intersection of the two circles. AB is the diameter, so we know that AB is the diameter of the larger circle, and they give you the equation of that line. So this is not the equation of the circle, that's the equation of the diameter. And they say it's 4x plus 3y is equal to -2. Good. Now they say CD over there has equation 4x plus y is equal to 13. So that line CD has the equation 4x plus y is equal to 13. And I want you guys to notice CD is a common chord for the two circles. So CD is a chord for the big circle, but CD is also a chord for the small circle. And that always happens, that the line that is drawn between the 2 points of intersection of two circles is a common chord. So it's a chord for both circles. Then it says the smallest circle has the following equation. So the circle has the equation x squared plus y squared minus 10x plus 2y is equal to minus 22. Now the first question to ask here is they say the following. Determine the coordinates of the center and the radius of the smaller circle. Now, because they want the center and the radius of the smaller circle, we're just going to use this equation that was given. But hopefully by now you should realize this is not the standard form of a circle equation. What do I need to do to put that in standard form? Come on, anyone?
You need to complete the square.
Exactly, you need to complete the square. So we need to complete the square there. So I'm going to say it's x squared minus 10x. And I'll complete the square there by saying half the negative 10. So minus 10 divided by 2 is minus 5. But if I square it, it becomes plus 25. Then I'm going to go and say plus y squared plus 2y. And then again, you take that, you half it, or you divide it by 2, which gives you 1. And then you square it, which is still just 1. The minus 22, careful then, don't forget this step. I've added 26 on the left-hand side, so I also need to add 26 on the right-hand side. Now I do the completed square bracket, and this is going to be x minus 5, because the value that goes in there was the value that you had when you halved that negative 10. Plus y plus 1 squared, and again, the value that you have there is the value you had when you halved it before you squared it to get what you actually added. And then minus 22 plus 26 is 4. So what I've got right there is I've got the coordinates of the center, because the center is going to be the point 5, negative 1. Remember to change the signs. So the center is 5, negative 1. And careful there, because this is always going to be the radius squared. So the radius squared is equal to 4. So that means I have to square root both sides, so r is equal to 2. And I don't have to write the plus minus because the radius is a distance, and because it's a distance, it's always positive. So that was pretty easy and straightforward, finding the coordinates of the center and the radius of the smaller circle. Right, next question. So the next question then asks, show that point C does not lie on the x-axis. Show that point C does not lie on the x-axis. Now, the only way to show that point C does not lie on the x-axis is to actually calculate the coordinates of point C. Now, in order to calculate the coordinates of point C, you need to realize I've got these two equations. I've got the equation of line CD, and I've got the equation of the circle. So this is finding the points of intersection between a straight line and a circle. And I did do an example in the video yesterday, but it was a very easy example. This is going to be a slightly more challenging example, because yesterday's example only had like an x squared plus y squared, I think was 25. So it was a circle where the center was around the origin. Okay, this one's going to be slightly more difficult, but it pretty much just involves solving these two simultaneously. So I'm going to rewrite this one saying y is 13 minus 4x. And then I'm going to write down the circle equation. Now, you do have the completed square version over there, but it's really not necessary to use the completed square version. You can actually use this version just fine. But what I'm going to do is every place where I find y, I'm going to substitute that 13 minus 4x into the equation. So the equation reads, it's x squared plus y, but now instead of y, I write 13 minus 4x squared minus 10x plus 2y, and again, instead of y, I write 13 minus 4x is equal to negative 22. So I'm going to put that into standard form. So that's x squared plus 169, and then calculator is going to be useful there, because that's going to be 13 times negative 4 times 2, which is then minus 104x. Plus 16x squared minus 10x minus 26 minus 8x plus 22 is equal to 0. Okay, then putting it in standard form, x squared plus 16x squared is going to be 17x squared. Then we've got over here minus 104 minus 10 minus 8. So that's going to be minus 122. And then over there, we've got 169 minus 26 plus 22. And that's going to be 165. And now just to save time, I'm going to use the equation function on the calculator just because it will make things go much faster. So I'm going to change it to the equation mode, selecting the quadratic equation, and I'm going to just use that 17 minus 122 and 165. And it says x is equal to 5,36, which we will round off to 1, although we don't really have to round it off to 1 decimal place. We can keep it like that for now. 5,36855. And if you really want to, you can store that into the calculator memory. I don't know if it does work. Let's quickly check. You can go Shift, Store, under A. No, unfortunately, it doesn't work to store it, so we'll just write this one down. And if I press the button again, it gives me a value of 1,807. Okay, so what you need to realize is the reason we've got these two values is obviously this line and that one cuts each other on two different points. The one point is over there and the other point is over there. Now, what stresses me out a little bit is the fact that the one is 1,8 and the other one is 5,36, which doesn't make a lot of sense because these don't seem to be that far apart from each other. So I might have accidentally made a mistake. I'm just going to quickly double check the working. Just make sure I haven't done anything wrong there. That is indeed 13 minus 4x. That is 100% correct. That is x squared plus 13 minus 4x squared minus 10x. That is right. Plus 2 times 13 minus 4x is negative 22. That's absolutely 100% correct. And as far as I can see, I haven't made a mistake here. Okay, I'm hoping I haven't made a mistake. So pretty much what's going to happen here is we're going to use these values. Now, obviously for C has got to be this earlier point. Yes? Did you spot a mistake?
The negative 26, should it not be positive?
Negative. Ha! Amy, you absolute darling. That is Amy, right?
Yes, ma'am.
Yes, you are an angel of light and mercy. This is going to be much, much better.
All right, thanks,
okay. So that's 169 over there. And then we have to go plus 26 plus 22. And that's going to be 217. That's going to look so much better. Okay, let's try that again. Hopefully it'll give me nicer values now. Okay, so we'll go equation mode again, and we'll say 17 minus 122 and 217, and that's going to give me x is 3,92 or x is 3,25. That's better. It's still not nice values, but at least they're closer together. That makes more sense in the context of the diagram, if that makes any sense. Okay, so we've got 3,255 over there. There we go, dot, dot, dot. And then the other one we had was 3,920. Dot, dot, dot. There we go, much better. Now, we are now going to say this is the coordinates for point C, because obviously point C is closer, whereas that one is slightly further away. So we're going to say point C then has this x coordinate. So I'm going to sub that back into my straight line to get the y coordinate, because what we are trying to prove is we're trying to prove it's not a point on the x-axis, which means the y coordinate should not be equal to 0. So if I sub this in, y is equal to 13 minus 4 times that and I did write quite a few decimals down, so that should be fairly accurate. We're getting minus 0,0216 dot dot dot. So even though it is very close to 0, it is not equal to 0. So because this is not equal to 0, I can then say, therefore, C does not lie on the x-axis. So I've done quite a few of these points where circles and straight lines intersect. And please don't get a fright when you get these irrational answers. They happen quite often, actually. They do happen quite often. That's why, and you've got the calculator, you can use the calculator, but you can see the reason I didn't like the original answers because it didn't correspond with the diagram. I always tell my kids, please people, every single time you find an answer, compare the answer with the diagram and ask yourself one simple question. Does this make sense? The previous one that I had that was wrong did not make sense. This one makes sense. Okay. Now here comes the question that is related to that perpendicular bisector. It says, find the midpoint of line AB. Now we know that AB is the diameter. So the midpoint of AB is going to be the center of the circle. So actually what they're asking me to do is they're asking me to find the center of the circle. But unfortunately, the only information I have here is this straight line. Okay. But luckily, I've got this chord right there. So I've got this chord. Now, why is it important to get to that chord? Well, simply put, it's a common chord. Okay. Now, because I have found the points of intersection here, which I know they're not very nice values, I completely agree with that, but I do have these 2 points there. I can then go and I can use the points to find the midpoint of that line. So I can actually find the midpoint of that line. Okay. And then once I've got the midpoint of that particular line, because I've got the center of this circle, which is somewhere over there, I will then know that if I draw a line going through here, there, the perpendicular bisector of this particular chord will go through the center of this circle. But that same perpendicular bisector, because it's a common chord, will go through the center of this circle. So, technically speaking, what I can then do is I can then say, I can find the gradient of this line, which I do have. I've got the gradient because I've got the equation of the line. So because I can find the gradient of this line, I can find the gradient of this line. And because this line goes through the center of the circle, which I've calculated over here, I've got a point on the line, which means with the gradient and with a point, I can find the equation of that line. And then logically speaking, where these two lines cut each other is going to be the center of the circle. So the calculations you'll see is not that difficult. But if you didn't draw this construction and you didn't have the knowledge that the perpendicular bisector will go through the center of the circle, there would have been no way you would have known to answer this question. So let's, yes.
So just to make sure that I understand exactly what you're saying that when there's a common chord between two circles, yes, the center of both the circles and the perpendicular bisector, or all of them are just collinear?
Yes, they're collinear. The midpoint of the chord and the center of the two circles will always be collinear, because this chord, because it's part of this circle, the perpendicular bisector will go through the center, so it goes through that point. And this chord, because it's part of that one, the perpendicular bisector will go through that center. So yes, they will always be the midpoint of the chord and the centers of the two circles will always be collinear. That is 100% correct.
Thank you, ma'am.
Okay, so first thing we're going to do, we're going to just find, we'll call this the radius. So we're going to find the equation of that radius. So to find the equation of the radius, we first go and we say the chord CD had that equation of y is equal to 13 minus 4x. We had it over there. Okay. So because it had that equation of y is equal to 13 minus 4x, the gradient of that chord is then equal to minus 4. So therefore, the gradient of the radius that we are looking at times that negative 4 is equal to negative 1, which means the gradient of the radius is then equal to a quarter. So this line has got a gradient of a quarter. Now we know it goes through the center of the circle, so it's the 0.5, negative 1. So I can then go and I can work out the equation of the radius by saying y minus minus 1, so y plus 1, is then equal to a quarter times x minus 5, which means y is equal to a quarter x, and this is going to be minus 5 over 4 minus 1. So minus 5 over 4 minus 1 is minus 9 over 4. So this is then the equation of this radius right there. But we then want to know, where does that radius, because it's a straight line, cut this diameter, and that's going to be the center of the circle. So I'm going to take this equation, which is 4x plus 3y equal to negative 2, and I'm going to sub this into that y value because I'm solving them simultaneously. You could have set them equal to each other, but solving simultaneously or setting them equal to each other is pretty much the same thing. So I'm going to say 4x plus 3 times a quarter x minus 9 over 4 is equal to negative 2. So that's going to be 4x plus 3 over 4x. So that's 4 plus 3 over 4, which is then 19 over 4x. And this is going to be minus 2. And that's going to be 3 times negative 9 over 4. So I'm going to just go and say it's minus 3 times negative 9 over 4, which is 19 over 4. Hey, that was actually quite easy. So x is equal to 1. And then I can sub it back into either one of the straight line equations. I'm going to put it into that one. So y is then equal to a quarter times 1 minus 9 over 4. So that's 1 over 4 minus 9 over 4, which is minus 8 over 4, which is then negative 2. So the center of the circle, which is the midpoint of line AB, is then going to be the point 1, negative 2. And that is worth 8 marks. So if you think about it, the actual calculation was not that difficult. But without this construction and without this knowledge about perpendicular bisectors of circles, you would have been completely and utterly lost in the woods. Everybody happy with this so far? You understand this. And this is knowledge you must have. It's got to go somewhere in your head where you realize these perpendicular bisectors are in actual fact very important. Okay, so that was the 5th type of questions they can ask. Now, the 6th type of questions they can ask when you're answering questions on circles is a line subtending a 90-degree angle in a triangle. So sometimes the question will start off where there's no circle present. There'll just be a 90-degree right angle triangle. And they'll give you these points. That's point A, that's point B, that's point C. And they'll ask you a bunch of questions. They might even ask you prove that CB is perpendicular to AB because you've got the coordinates. I just decided to save some time and show you it's perpendicular. But I mean, if they ask you to prove it's perpendicular, you'll just work out the gradient, and multiply, and you'll find it's perpendicular. Now, this right there, incredibly important for circles, because any line that subtends a 90-degree angle on the circumference of a circle is the diameter of the circle. So in other words, if I draw a circle, and you guys have seen how horrible my circles are, that one was all right-ish. Okay, so if I draw a circle around going through these 3 points, this will always be the diameter of the circle because it subtends the 90 degrees. So the moment I know this is the diameter, I can find the midpoint of that diameter, because obviously the midpoint of the diameter is going to be the center of the circle. So I can say the midpoint minus 2 minus 1 over 2, and then 3 minus 9 over 2. So the midpoint is going to be the point minus 3 over 2, and that's going to be minus 6 over 2, so that's minus 3. So now I've got the midpoint, which is the center of the circle. So this is the center of the circle. Okay, and then I can find the radius, and the radius I can simply find by finding the distance from there to there. So this is going to be the radius right there. So I can then go and I can say the radius is then equal to minus 1 minus minus 3 over 2. So plus 3 over 2 squared. And then minus 9 plus 3 squared. And this is obviously the radius, but I'm going to make it the radius squared because we need the radius squared anyway to find the equation of that circle. So that's going to be 145 over 4. And then I've got the center of the circle, I've got the radius squared of the circle. So therefore the equation of that circle is x minus 3 over 2, so x plus 3 over 2 squared, plus y minus minus 3, so y plus 3 squared is then equal to that radius squared, which is 145 over 4. Everybody got that? Not too bad. But then again, you need that information that the diameter subtends a 90-degree angle on a triangle. If you don't have that information, you're stuck again. Right, so let's look at this one. This one was in the 2018 paper. And what they did was they said, a farmer uses a drone to check his fences for any damage. The drone flies in a perfect circle and passes directly above points A, B, and C. So it says the drone flies in a perfect circle, goes past A, B, and C. So what they're telling you is they're telling you A, B, and C are on the circumference of the circle. Then they also say that points A, B, C, and D are on the same horizontal plane. That's just to tell you it's flat. So that's pretty easy. D lies on the x-axis. So they give D there as a point on the x-axis. And they say at present the angle made between the line AD and the x-axis is 45 degrees. So they're telling you this is then 45 degrees. Okay. Now, the first question they ask is they ask, determine the current coordinates of point D. Now, to determine those current coordinates of point D, you need to realize D is the x-intercept of line AD. Currently, we don't have the equation of line AD, but because we've got this point, which is the point 1, negative 2, and I've got this angle, I can actually work out the equation. Because, believe it or not, if I go and I just straighten this line through, because this is 45 degrees, this is 45 degrees, which is the inclination of that line. So I can then go and I can say the gradient of AD is then equal to the tan of the inclination, which is 45. And by the way, hopefully you guys should know tan of 45 is equal to 1. So the gradient of that line is 1. And I've got the points on the line, so I can say y minus minus 2, so y plus 2 is equal to 1 times x minus 1. So that's then going to be the line y is equal to x minus 1 minus 2, which is minus 3. And then if I set this equation equal to 0, because I want to determine what the x-intercept is, I've got x is equal to 3, which then means that D is the 0.30. Okay, so simple, straightforward, finding the x-intercept of that line. Now the next question then says, calculate the size of angle ABC. So if I want to find the size of angle ABC, you should notice, and I did do revision of this on the notes on the grade 11 revision, where I said, if you want to find the angle between two straight lines, I always need to find, first things first, the inclination of the two lines. So if I extend this line going down, I need to find the inclination of that line because that's one of the lines that forms this angle. And I also need to find the inclination of that line right there. So we can call this one alpha and we can call this one beta, because hopefully you guys should realize that in this case, this one's going to be slightly more tricky simply because of the fact that that plus that is going to be equal to that, which then means once I get that angle, it's angles on a straight line. So I can actually use angles in a straight line there. But the point is always calculate the inclinations, because the moment you calculate the inclinations, it's actually quite easy to calculate this one. Right, so let's take a look. We need the gradient of BC and we need the gradient of AB. So the gradient, I never know why they give you so little space if it's out of 4 marks. I mean, they're giving you 3 lines to do a question that's out of 4. But anyway, good luck with end of the year in space. So for BC, we've got 5 minus 1 over 2 plus 2, which is then going to be 4 over 4, so the gradient of BC is 1. Then for the gradient of AB, we've got 1 plus 2 over minus 2 minus 1, which is going to be 3 over negative 3, so that's going to be negative 1. So that's actually quite easy, because the moment the gradient is 1, we know this is going to have an angle of 45 degrees, and we can know this is going to have an angle of 135 degrees, so this is actually going to be very easy. This is 135, so this is 45, this is 45, which means this is 90, which means that's 90 as well. And you can figure that out by saying the tan of alpha is 1, so alpha is equal to 45 degrees. And there the tan of beta is negative 1. And please remember, when you use that shift tan minus 1 for negative 1, and you end up getting to that negative angle, I did tell you guys about that. Remember, inclinations can never be negative, so you just have to add 180. So that inclination is the 135. And then finally, that means if this is 45 and this is 135, then this is 45, this is 90, this is 90. So I can just go and say that means angle ABC is 90 degrees. There we go. Okay. Now, the next question they ask, and this is the important question. How far to the right must D be moved along the x-axis so that the drone will fly directly above it on its circular flight path? So listen again. How far to the right must D be moved along the x-axis so that the drone will fly directly above it on its circular flight path? So I need to now move point D over to this point right there. Got it. So that's what I need to do. I need to move this over. But in order to do that, D must now become the x-intercept of the circle. That's what I need. So if I know what the x-intercept of the circle is, I know how far I can move D, because currently D is at the point 3, 0. So I need to know from 3, 0, how far do I need to move it over? But you will notice that I don't actually have the equation of the circle at the moment. So how can I work out the x-intercept if I don't have the equation of a circle? Simply put, like this. This line right there is what of the circle? Can somebody tell me, what is this line of the circle?
The diameter.
Exactly. Because they've just led us to prove that this is 90 degrees. And because they've just led us to prove that this is 90 degrees, that's the diameter. So because this is the diameter, I can do exactly what I did in the previous example, which is find the midpoint, find the radius, then I've got the equation of the circle, and then I can just set y equal to 0 to find the x-intercept. So I'm not going to do that right now. I will go, and when I put the notes up on the Google Classroom, I will finish this example, and I'll make sure that when these notes get uploaded, that will be a completed example. But like I said, we need to move on, and because we need to move on, and we've already done an example where you find the equation of the circle using that diameter, I don't think I need to explain that again. But do you see how all of these little questions keep on creeping up in different places in exams? Okay, so I will complete that before I upload the notes. Now, next one. The next one talks about the distance between a point of contact and another point on the tangent. So we've spoken about how to get the equation of a tangent. So when you get the equation of a tangent, you've got that line equation by finding first, because they normally give you this point of contact. They give you P and they say, this is the coordinates of P. So you can then go and you can find the gradient of the radius, which obviously is perpendicular to the tangent, and then you can set that point in to get this. Now, what makes this question quite interesting and slightly tricky to do is the following. If I then go and I draw the radius in there, we know that this is going to be 90 degrees. And if I connect this, then what we have over here is a 90-degree triangle. So they will normally ask you, what is the distance of this? That's what they ask. They ask you, what is the distance of this one? And you will normally have the length of the radius, so that you will have. You will also have the center of the circle, and you'll have this point. So you can use the distance formula to calculate that. So the only way to get that PQ is to construct that 90-degree triangle and then say PQ squared is going to be equal to OQ squared minus the radius squared. Because remember, the radius is equal to OP. And you can do that using Pythagoras. So let's look at an example on how they also sneak these questions into final exams. So this one was in the 2018 final exam, question 2, and they said, in the diagram below, center circle O is drawn in the Cartesian plane. MN is a tangent to the circle at M. N is a point outside the circle with coordinates N being 11, -5. So I'm going to put that 11, -5 in there. Then they say, write down the size of angle OMN. So we now know already, because MN is a tangent and we know O is the center, we know this is the radius. So I can then immediately just go and say OMN is equal to what? This is an easy question. Come on, guys. Are you still there?
90.
90.
90.
Great. And my reason is going to be tan rad. Tangent perpendicular to radius. Thank you very much. Right. So that was simple. So I can put that 90-degree angle in there. Now the next question is, they say, if the equation of the circle given above is this, then please calculate the coordinates of O. So O is my center of the circle, which, because they've given me this equation, means I just need to do this one completion of the square. So I can go x squared minus 8x, and I can say half that, square that, so this is going to be plus 16, plus y plus 4 squared is equal to 9. And please remember, I've added 16 there, so I need to add 16 there. Please don't forget that. That's such a common mistake to make, where you add the completion of the square on the left-hand side and you forget it on the right-hand side. So this is then going to be x minus 4 squared plus y plus 4 squared is equal to 25. So the coordinates of point O is very simply 4, -4. And the length of OM, which is the radius, is then equal to the square root of that 25. So the radius is just equal to 5. And now comes the question that I've just spoken about. Calculate the length of MN. So I now know this is the radius, this is 5. I know point O is the point 4, -4. So I can find the distance of that one, ON, because I can use the distance formula to find the length of that line, and then I can just use Pythagoras to find that. But again, if you did not go and understand your constructions or all this information, you wouldn't have used that Pythagoras. So first we'll calculate ON, which is 4 minus 11 squared plus minus 4 minus minus 5, so plus 5 squared. and that's going to be equal to 5 square root 2. And then we can go and we can say, but mn squared is then that 5 square root 2 squared minus the 5 squared, which is then your Pythagoras. Which then means that mn is equal to 5, which, just for interest's sake, not that you really needed to know this, but that makes this one an isosceles triangle because this is 5 and this is 5. So it's an isosceles triangle, but that wasn't really necessary for you to know. Right. Now, last one. And this one I'm going to put an asterisk on over here. And the reason I put an asterisk on over here is this is a question that it's not a question that they really ask. Okay. But it is a question that can pop up in other ways. So if you want to calculate the points of intersection between two circles, most of you guys will say, oh, that's pretty easy and straightforward. The points of intersection between two circles, I just have to set them equal to each other, or you can also say, I just need to solve them simultaneously. But what you need to realize is two circle equations. The one has got an x squared and a y squared and an x and a y. The other one has got an x squared and a y squared and an x and a y. You've never done that. You've never simultaneously solved two circle equations. Every single time you've done it so far, you've had a straight line and a circle. So you managed to find the points of intersection between a chord and a circle, or a secant, meaning a line that cuts the circle and a circle. So in this case, you'll see the following happen. If I want to find the points of intersection between two circles, you've got to expand the circle equations, meaning if it's in that standard form of x minus a squared plus y minus b squared, you've got to expand it. It's got to be in that one where it goes x squared minus 10x plus y squared minus 4x. It's got to be in that format. So you expand the circle equations. Then you want to subtract the circle equations, or, by the way, you can also set the two equations equal. So subtract the circle equations or set them equal, and I'll show you what I mean just now in an example. But when you set them equal, you will not get an answer like 4 or 5. The result will always be a straight line equation. Now that straight line equation that you get, people, is this. So by setting the two circle equations equal to each other, you will find this straight line equation. So you will actually find the straight line equation of the common chord. And then, because you have now a straight line equation, you can then solve the straight line equation and one of the two circles simultaneously. And that will give you the points of intersection. And this is why they generally don't ask it, because it is quite a cumbersome way of doing it. I am going to do one example here, and then I'm going to actually show you a shorter way that you could have potentially done this one if you wanted to avoid this. But you need to be aware of the fact that when you subtract two circle equations, or when you set two circle equations equal, you will always get a straight line equation, and that straight line equation will always be the common chord AB. So sometimes they might not actually ask you to find the points of intersection. They might just ask you to find the equation of that common chord. And to find the equation of that common chord, just go and subtract or set the two circle equations equal to each other. So in this question, question 11, they said, two circles are given. There's the first circle, there's the second circle. Show that the circles do not intersect. Now, I'll do the very short version, which is actually quite easy to do after this, but I'm first going to go and I'm going to try and find the points of intersection between the two circles. So to do that, I'm going to expand these circle equations. So that's going to be x squared minus 6x plus 9 plus y squared minus 4y plus 4. And you'll see I'm going to go and say minus 9 is equal to 0. There's the first circle equation. I'm going to simplify it slightly by saying x squared minus 6x plus y squared minus 4y And then I've got 9 minus 9, which is 0 plus 4, so that's plus 4 is equal to 0. So that's the first circle, that's circle A. Then for circle B, I'm going to do this, and I'm going to say this is then x squared minus 18x plus 81 plus y squared plus 2y plus 1 minus 9 is equal to 0. And then just simplifying it, x squared minus 18x plus y squared plus 2y. And this is then going to be 81 plus 1 minus 9, which is then 73. So if I go and I set these two equations equal to each other, so if I go x squared minus 6x.
Ma'am.
Yep.
I think your 73 is supposed to be positive.
I'm so happy you're awake. Why do I keep on changing positive to negative today? I'm sure there's like some type of Pavlovian or Freudian or psychological issue there. Anyway, so that one, thank you very much, Michelle. And then x squared. Beg your pardon?
Is it?
Pleasure. I hope that's what you said. Or did I get the person wrong? There we go. Okay. So like I said, the moment you set these two circle equations equal to each other and you clean it up, you'll see over there I'm going to have x squared minus x squared, which means this eliminates. Over there I'm going to get y squared minus y squared, which means this eliminates. But you are going to get the following situation where you say, I've got minus 6x plus 18x, which is then going to be 12x. Then I'm going to get minus 4y minus 2y, which is going to be minus 6y. And then I'm going to get 4 minus 73, which is going to be minus 69. And that right there is then the equation of a common chord should these two circles actually intersect. And then you could go and you can solve this one simultaneously with either one of those two equations to then go and prove that there's no real solution. But I think you guys agree this is a very long way of doing it. This is a super, super long way of doing this. And I mean, just to then go and substitute that into one of those two and then get to a situation where when you type it into your calculator, it gives you non-real answers. And that's what would happen. It'd give you non-real answers because there's no solution. This is not a very good way to do it. So the only reason I did this was to show you how, when you set two circle equations equal to each other, you end up with a straight line. And if these two circles did in fact intersect, this would have been the equation of the common tangent. But like I said, this is silly because the two circles don't even intersect. An easier way to do this, much easier way to do this, I'm just going to put like a little bit of a line through there and say, too much work. Would have been to use something that I have discussed with you in the previous notes. So I don't know if you remember in the previous notes where I went and I said, when you look at the place where two circles intersect, and they want you to do this, and this is from the previous notes from yesterday's video, how to determine whether two circles intersect or not. So the easiest way to do it is to just work out the distance between the two centers. Because if the distance between the two centers is less than the sum of the radii, then these two circles will intersect in 2 points. If the distance between the centers is equal to the sum of two radii, they touch each other. And if the distance is greater than the sum of the two radii, they don't cut each other, which in this case would have been so much easier to do. But again, you needed to be aware that this was an option. So we're going to work out the distance from A to B by saying A is the point 3, 2. That's the center of that circle. And B is the point 9, negative 1. So if I work out from A to B, so from the center of the one circle to the center of the other circle, I get 3 minus 9 squared. That's 2 plus 1 squared. And that's going to give me 3 square root of 5, which if I just change it to a decimal, it gives me 6,708. I'm not going to round that off just yet. Now, the radii of both of these circles are 3, because the radii squared there is 9, the radii squared there is 9. So the sum of the radii, so the radius 1 plus radius 2, is then equal to 3 plus 3, which is equal to 6. So what can you tell me here? The distance between the centers is bigger than the sum of the radii, which means it looks like this. The distance between the two centers is bigger than the sum of the two radii, so therefore the circles do not intersect. And this is much shorter than trying to go and find the 2 points of intersection, which, by the way, we were just up to the point where we found the equation of the common chord, which is actually not even a common chord because these 2 circles don't intersect. And then if you had subbed it back in there, which would have been about another page of algebra, you would have found no real solutions. So this is much, much shorter. And this then also gave you an example of this one that I did discuss in yesterday's video, but I didn't really do an example. So I think you guys agree, much easier to do. So this is pretty much the questions they give. I'm not saying they can't come up with something else, but these are the ones that I found pops up again and again and again. So that's why you have these background knowledge that you need. I've given you guys a worksheet, and that worksheet contains, I think, the last 3 or 4 years worth of past papers. So the worksheet and the memo for the worksheet is on the Google Classroom. You can start going through it. If you get stuck, just send me an email over the weekend, because obviously you've got the quiz on Monday. So if you want to get something sorted out in your head, it's probably a good time to do it then. Okay, let me just stop the recording here.